Okay, let's look at this version of the test. Okay, they want f composed with g evaluated at 2. If there's a number in there, your answer is going to be a number, not an expression in x. So f composed with g is the first one, f evaluated at the second one. And so what you have to do first is evaluate g at -2. And so that's going to be -4. And so now we want f evaluated at -4. And so if I use this formula, but I plug in -4, shush, 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 shush. Okay. All right, one of my dogs likes to talk. Okay. So -4 all squared is 16, then plus 8 plus 7 is going to be equal to, that's going to be 15, and I'll have 31. I should have 31. Now we put a 31 in there, if I didn't make a mistake. Okay, now on the next one, we want g composed with f evaluated at 2. So it's going to be the first one evaluated at the second one. And I need to find that first. So my x value is 2. So I come up here on x until I find x equals 2. That's going to be the column. And the function is f. And so where do they meet? They meet up at 1. So this is going to become g evaluated at 1. And now my x value is now 1. And the function I'm looking at now is g. And these intersect at 0. And so my answer is going to be 0. Okay. All right, now we want f composed with g evaluated at 7. All right. The first one evaluated at the second one. Okay, g is in the red. So we want g evaluated at 7. So I'm going to come here to x equals 7. And this point here is 7, 5. So g maps 7 into 5. And so g evaluated at 7 is equal to 5. And now I need to find f evaluated at 5. So I come here to the blue graph and I find x equals 5. And there's the point. And that point is 5, 2. And f maps the x coordinate into the y coordinate. So my final answer here is 2. Only give the final answer 2. Okay. All right, now we need to find the inverse. There is a 4-step process. The first step is you replace f with y. Then you swap x and y. Then you solve for y. So I'm going to add 8 to both sides. I'm going to swap sides because I want to get the y by itself on the left. Then I'm going to take both sides to the 1/3 power. And so 3 times 1/3 is 1, which is what I designed it to be. And then I'm going to subtract 2 from both sides. And so I have y by itself now, and I have solved for y. So my answer will be f inverse is equal to x plus 8 to the 1 cubed to the 1/3 power minus 2. The 1/3 power is the same as a cubed root. So there's the one that we want. Okay. So I'm going to click on that one. Okay. All right, now we're asked for F inverse. And if you have a point in F, then what F does is it maps X into Y, and what F inverse does is it maps Y into X. So if we want F inverse of 11, we need to find the point whose Y coordinate is 11. And so here we have it, and F inverse will map 11 into -7. So the answer is going to be -7. Okay. Express that in logarithmic form. Okay. Well, we had a conversion formula. And if I'm going from exponential to logarithmic, we have that. And so what I need to do, let me write that bigger. I need to identify the A, the Y, and the X, and then write this down, and then go from red to black. Okay. And you should be able to check that you would get this, because how do you get from logarithmic to exponential form? R to the S is equal to the argument. And so, yes, that works. So my answer is going to be the first one there. Okay. Now let's do that one. Okay, well, the easy, quick way to do that one is, and again, let me write it bigger. Then it's the base raised to that power is equal to the argument, which is the only thing that's left over. S to the R equals T. S to the R equals T. Okay. Write that as one logarithm. Okay. I can put these together using rule 2, and that will become a logarithm of a quotient. And then I'll write this one. I need to use rule 3 first to get that 3 out of the front. And now I can put these together using rule 1, the product rule. And when you have a fraction times something that's not a fraction, that gets multiplied in the numerator. This is an actual problem from a final exam. Okay, and that's going to be equal to B. And so we're going to write B in there. Okay. Okay, now this one asks you for the extraneous solution. And this is, in recent years, what the department will ask you for, because they know that there are phone apps out there and programming in your calculator where it just gives you the solution. Phone app or your calculator won't give you the extraneous solution. So you have to know how to solve using the methods that were taught in the labs and the PDF and the examples. Okay, so if I'm going to solve this, I can do the conversion, but I have to have that as a single logarithm. So using rule 1 to what's underlined there, I can use the product rule. and I'll have that. Now, since it's log without a base, it's understood that the base is 10. And now I'm going to convert it into exponential form. That raised to that power is equal to the argument. So 10 is equal to, now I'm going to multiply these together, 5x squared, and 5x times negative 1 is minus 5x. This is a quadratic. I can solve a quadratic if it's equal to 0. Subtract 10 from both sides. I can divide everything by 5, every term by 5. And now I can factor that. Two numbers that multiply together to give me negative 2, but add up to give me negative 1. That would be negative 2 and positive 1. And I can see the solutions to this are 2 and negative 1. Now, these are solutions to the quadratic. You have to check the original equation and make sure they're allowed in the original equation. So if x is equal to 2, this will become log of 5 times 2, which is log of 10, which is fine, plus log of 2 minus 1, which is log of 1, and log of 1 is 0. And log of 10 taken at base 10 is equal to 1. So this is a solution. You were not asked for the solution. You're asked for the extraneous solution if there is one. So this is an actual solution. And if you had used a phone app on this, this would tell you what the answer was. But you weren't asked for the solution. You're asked for the extraneous solution. Now, is this one allowed? It depends. We have to go back into the original problem, negative 1. Well, if I come here and x is negative 1, that becomes the log of 5 times negative 1, which is negative 5, and you cannot take the logarithm of a negative number. So even though this was a solution to the quadratic, it's not a solution to the original equation. This is your extraneous solution. So the solution set, the actual solution, is 2. The extraneous solution is the one that didn't work in the original equation. So it's not a solution. It's the extraneous solution. So we have to put in negative 1 here. Okay. All right. Again, it's asking for extraneous solution. Oh, what happened here? Okay. And so let's look at that. I can put these together using the product rule. And now, since it's log without a base written, the base is 10. Now I'm going to convert into exponential form. 10 to the first power is equal to the argument. So I'm going to have 10 is equal to, and if I FOIL this, I'll get x squared minus x plus 2x, and then minus 2, and then subtract 10 from both sides, because you can always solve a quadratic if it's equal to 0. Try to factor. If you can't factor, then take the quadratic formula. Two numbers that multiply together to give me negative 12, but add up together to give me positive 1. That would be positive 4 and negative 3. And now the solutions to this quadratic are going to be negative 4 and positive 3. Now, are they solutions to the original equation? I'll need to go back and see. If I plug in negative 4 into here, I get log of negative 4 plus 2, which is negative 2, and that does not exist. So this is an extraneous solution because it was a solution to this equation, but it's not going to work in the original equation. Now, what about 3? Will 3 work in the original equation? I'll have the log of 3 plus 2. And here I'll have the log of 3 minus 1, and both of the arguments are positive, so 3 will work. So 3 is the actual solution, but you were asked for the extraneous one, and the extraneous one is going to be negative 4. Okay. All right, again, we're asked for extraneous. I can solve using uniqueness if I have single logarithms on both sides. So if this problem had just been that, then I could have gotten rid of the logs and said x minus 2 equals 4x and solve it from there. But to use uniqueness, you have to have single logarithms on each side. I can use rule 1 to make that into a single logarithm. It's going to be the log of, and it's the product rule. So I multiply the two arguments. Now I have single logarithms on each side. So using uniqueness property, I can just get rid of these logs. And I have, I'll do it like this. This is equal to that by uniqueness. So now I'm going to FOIL this. I'm going to have x squared minus 2x plus 4x, and then minus 8 equals 4x. Subtract 4x from each side. 2x minus 4x is minus 2x. And now, are there two numbers that multiply together to give you negative 8, but add up together to give you negative 2? Negative 4 and positive 2. Now, what are the solutions to this? What will make it 0? If x is 4, or if x is negative 2? Now, if x is 4, this will become 8, so it's positive, and that will become 2, and that will become 16. So I have positive arguments everywhere. So that is an actual solution. It's allowed. It's in the domain. But now I have to go back and check with negative 2. If x is negative 2, this becomes log of base 6 of positive 2, which so far is okay. If x is negative 2, then the argument inside the parentheses becomes negative 2 plus 4, which is positive 2. But here, if x is negative 2, then this argument becomes negative 4, and you can't take a logarithm of a negative number or 0. So this is extraneous. It's not a solution to the original equation, although it was a solution to this quadratic. So the extraneous solution is negative 2. As I said, nowadays they tend to ask for the extraneous solution in these problems. Okay, solve this exponential equation. All right, well, what I'm going to do is I'm going to convert it into logarithmic form. So there's my A, that's my Y, that's my X. And going from red back to black, now if the base is E, we have a shorthand for that. Now we need to solve for X, so we're going to subtract 2 from both sides. And so this is my solution for X. That's an exact solution. So my answer is going to be D. Find the exact solution to that, so let me write it big. Now, ln is shorthand if the base is E. And I'm going to go from logarithmic form to exponential form. So raise that e to the 5th is equal to the argument. Now, we need to solve for x. So I'm going to subtract 1 from both sides. And to solve for x now, I need to divide both sides by 7. So that's my exact solution. So I need e to the 5 minus 1 over 7. And so it's going to be that one. Okay, find the exact solution to this. All right, I need to put these together as a single logarithm. So we're going to use rule 2, the quotient rule. And in the numerator, I'm going to have x plus 7, and in the denominator, I'm going to have x minus 2. Now I'm going to change into exponential form. So this raised to that power is equal to the argument. So I have 8 is equal to x plus 7 over x minus 2. Now get rid of the fraction, so we're going to multiply both sides by x minus 2. So that will cancel. And then 8 times x minus 2 is going to give me 8x minus 16. Now I'm going to subtract x from both sides. And 8x minus x is 7x. And then I'm going to add 16 to both sides. And 16 and 7 is going to give me 23. And then I'm going to divide both sides by 7. So I should be getting 23/7. Okay. And that's an exact answer. It says to find the exact solution, so I'm going to put 23/7. I'm not going to use any parentheses. Okay. Let me scroll down. Okay. Compounded quarterly. That tells me n equals 4, and this is the formula that I need. 6.4% interest. That means R is going to be 0.064. And he opens the account with 3,500. That's our P. And how much will he have in 10 years? T is equal to 10. And we want to find how much in 10 years. We want to find A. So I'm going to put this in my calculator all in one go. And 4 times 10 is 40. So I'm going to put 40 in my calculator. Okay. Let's get my calculator up here. So I want 3,500. And then times, so parentheses, 1 plus 0.064 divided by 4, all to the 40th power. Now, if you figure out what's inside that parentheses first, you'd better take it to every single last decimal place that shows up. So this is why I like to do it in one go, because I won't make the mistake of rounding. Some students work out the parentheses first, then take it to 40th power, then multiply it by 3,500. But when they do the parentheses first, they round. They cut it off. They've introduced rounding error. Here, if you do it all in one go, you won't have any rounding error. So my answer is going to be, use the dollar symbol and give your answer in dollars and cents. Okay. I'm going to enter here. Okay, just make sure I got that. Okay, so that's what I'm getting. Okay, let's keep going. How much money should she ask her parents for now? how much should she start with? So we're going to need to find P. It's continuously compounded interest, so that's the formula we have. And she needs 11,000 in 4 years, so T is equal to 4, and her ending amount, so after 4 years, is 11,000. Okay. And she's investing it at 10%. So R is going to be 0.1. Okay. Uh, 0.1 times 4 is 0.4. Okay. And then to get P, I just need to divide both sides by e to the 0.4. So, because those will cancel, and that'll be my starting amount. So let's see what we get here. So 0.1 times 4 should be 0.4. Yeah, so 11,000 divided by, and then e to the 0.4. Do the second key and the ln key. E to the 0.4. Close parentheses. Okay, so according to my calculator, that's going to be $7,373.52, which is matching that first selection there. Okay. Okay. Now we've been given the formula. Your amount after time t is equal to that. Okay. What is the half-life of the substance? Okay. You want to find the amount of time. The half-life is to find the amount of time, t, when A of t is a half what you started with. And you can see from this formula, your starting amount is 400. And a half times 400 is 200. So find t when A of t is equal to 200. But you have another formula for A of t here. So put these two formulas equal to each other and solve for t. Okay. Divide both sides by 400. And over here on the left-hand side, that will become a half. And so now I'm going to take, since the base is e here, I'm going to take ln of both sides. And rule 3 of logarithms, if you have a logarithm to a power, the power comes out the front. Then times ln of e. But ln of e is just equal to the number 1. And that's part of a product. So I have negative 0.077t times 1. So I can get rid of that. Now, you're supposed to find t. How long will it take until you have half of it left? That's the half-life. So I'm going to divide both sides by whatever's multiplied by t. 0.077. And then with cancellation, I'll just have t left. So t is going to be equal to that. This is what we put in our calculator. Only give the number and round your answer to the nearest day. Okay, so I'm going to need, let me clear this, ln of a half, I can put in 0.5, close parentheses, divided by negative 0.077. Okay, and to the nearest day, that's going to be 9 days. Do not include any words with your answer, only give the number, the instructions say. So 9. Okay. All right. Okay. Bismuth has a half-life of 5 days. If we start with a sample of 600 milligrams, how much will remain after 30 days? Okay. Well, let's get our formula. And this is a decay problem, so our K is going to be negative. Okay. Now we start with a sample of 600 milligrams. Okay. So my starting amount is going to be 600, so I can refine that formula. And we're told that the half-life is 5 days. So the amount after 5 days is equal to half of what you started with. But I have a formula here, and if I let t equal 5, it'll become this. E to the k times 5, which I'm going to write as 5k. And now these two are both the same thing. They're equal to a of 5. So I'm going to put them equal to each other. And this is how I'm going to find out what k is. I'm going to divide both sides by 600. And so you get a half here. And I'm going to take ln of both sides. So ln of a half is equal to, the third rule says what's in the exponent can come out the front. So you're going to have 5k times ln of e, but ln of e is just the number 1. And k is going to be ln of a half, or 0.5, all divided by 5. So I can come back to my original equation here. And k is going to be ln of 0.5 over 5. And then we're going to have t up in here. And then finally, the question is, how much are you going to have after 30 days? So the thing they want you to find, how much will remain after 30 days, they want you to find a of 30. And 30 divided by 5 is 6. So I'll have 6 times ln of 0.5 up in the numerator. And that's going to be my answer. Now, let's see what that is in the calculator. See if it's anywhere close to any of those. Let me clear that. 600. Then second ln, so e to the power of 6, then ln 0.5. Close parentheses for ln, close parentheses for exponent. And I'm getting 9.375. Okay, and that will be that next to last one. That one. Okay. All right. I'm going to need my calculator. And let me clear that. And I'm going to need to make 2 lists. The first one is 1, 2, 3, 4, 5. The second one is the second list, so 1.9, 3.1, 5.5, 7.6, 12.3. And I'm just going to quickly check that I put those in there correctly. Then I'm going to press Stat, Calc, and it says use exponential regression. There it is. And I'm going to use list 1 comma, and list 2 for my y. List 1 for x, list 2 for y. Okay, so that tells me, now these are all taken to 2 places. So we have that y, let me do that in black, y is equal to a times b to the x. And if I take a to 2 places, I'm going to get 1.24. And then times b to 2 places is 1.59 to the x. All right, it looks like that one there. I'm going to choose that one. And then the last one wants to know the predicted population for 2005. Okay, so again, I'm going to need 2 lists. And I need to clear these lists out. So I'm going to come down here and clear list 1 and 2. Okay, so what I'm going to do is I'm going to let 0 represent the year 1900. So this is what I'm going to make my list. And then the year 2000 will be 100, because the year 2000 is 100 years after the year 1900. So here's how I'm going to put in my list. My list 1 is going to be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then I'm going to have 76, 92, 106, 123, 131, 150, 179, 203, 227, 250, 281. Now this one I will check. 281, 250, 227, 203, 179, 150, 131, 123, 106, 92, 76, and 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, that looks good. I'm going to come over here and I'm going to come down to exponential regression with list 1 and list 2. Okay, so and I'm going to take it to at least 4 places. So taking this to 4 places, gives me that. Okay. And now what is predicted population for 2005? Well, if the year is 2005 and t is equal to 0, the time started in 1900, then 2005 is 105 years after 1900. So I'm going to plug in so that should be a t into that equation. Okay. So here they used an x, but in my equation here, I let t represent x equals 1900. Okay. So I'm going to put that into my calculator now. So I'm going here, and I'll have 80.2131 times 1.0129 to the power of 105. Okay, and if I round that to the nearest whole number, then the answer is going to be 308 million. Okay, and so that completes this test.